Now the next bit we actually need to understand is these charge numbers here. Now last lesson we talked about what they mean. If it's positive, it's a cation, and that represents that there is a net positive charge. If it's positive, it also means that it's lost electrons, because electrons are negative. If you lose a negative charge, you essentially gain, or you make the atom more positive. This is an anion, so if it's negative, it's an anion. That implies that you have lost, or you have gained electrons, sorry. What you can also see here is it's 2 minus, instead of being just minus by itself. So this 2 here implies that we've actually lost, or gained, I don't know why I keep saying lost, gained 2 electrons. Okay, so that's what we have. Now cations are always metals, besides one, which is hydrogen, and anions are always non-metals. Okay, so the next step is to work out where each one is on your periodic table. So if you look at your periodic table here, okay, if we try and draw sort of an arbitrary line to separate everything, your non-metals is everything around this region here. Now I specifically didn't do the noble gases because remember, the noble gases have a full outer valence shell, so they have the most outer electron shell is full. They're not going to form any ions. Hydrogen also is a special case, so it's a type of non-metal that will just give off its electron rather than gain. And then you can see here, all these metals here, they are going to form cations. So these will form cations and lose electrons to obtain a full outer shell. The idea being you want an outer shell that's full, so all of these metals, all of these non-metals will want to have the same electron configuration as a noble gas by losing or gaining outer shell electrons. Once the electron shell is full, then we will have a stable atom or stable ion. Okay, so let's look at what's happening here. So we said before sodium is +1 as its ion form. So why is that the case? If you actually have a look, sodium has an atomic number of 11. So that number right there, just above this pointer here. Okay, so there's 11 protons, so that's plus. We said that with an atom, you have the same number of protons and electrons, so we also have 11 electrons. Electrons are negatively charged, so that's why it's -11 there. If I've lost an electron, meaning by I've lost a negative charge, okay, that means I only have 10 electrons compared to 11 protons. So overall, I have a net +1 charge here. Now, if you actually look at the diagram down here, you can see where that electron has gone. So this, the most outer shell, so the outer shell, we also call it the valence shell. Any electrons in the valence shell is called a valence electron. And what's actually happening in the formation of an ion, this electron here is moved out of the valence shell. Okay, remember, a full outer shell for number 3 will need 8 electrons. But obviously, it's a lot easier to lose this 1 electron than it is to gain 7 additional electrons here. So by losing this, you can see now the valence shell of sodium is completely full. And that's really what the atom is trying to achieve when it's forming a bond. By making a full valence shell, this is now stable, and so, you know, it won't react. And that's kind of the point. Fluorine is a non-metal, so it's going to gain an electron. If you count the outer shell here, we actually have 7 valence electrons. Now for the second shell, the maximum number you can have is 8 electrons. Okay, so it can either lose 7 to get a full outer shell here, or it can gain an additional 1 here to get a full outer shell. Now that's pretty easy to see that gaining the additional electron is going to be a lot more easier to do. So that's what we have here. Gains an additional electron, that's where our additional electron here is. Remember, electron is negative, so if we gain a negative charge, we have a net charge of -1. Okay, so that's what we have. We have some other fancier ones called polyatomic ions. We won't need to worry about it too early, just yet, but just to give you an idea, ions are obviously charged atoms. Polyatomic is charged atoms but multiple types. So something like ammonium ions, it actually has nitrogen and hydrogen, so those are two different types of atoms. You have nitrate, nitrogen and oxygen, sulfate, sulfur and oxygen, and phosphate, phosphorus, or phosphor and oxygen there. Alright, some ionic compounds we're going to look at. As you can actually see, ionic compounds is the formation of a metal. So sodium's a metal, and chloride is a non-metal. So just to get the definition out, a ionic compound is a bond between a metal plus a non-metal. The more accurate definition is actually it's a bond between a cation plus an anion. So that's what you're looking at here. In this case here, sodium is our metal, or our cation, and chloride is our non-metal. You can see that the naming is slightly different as well. And then we have a carbonate. So some common ionic compounds is sodium chloride, table salt, so the salt that we eat. If you hear me say salt in any other context, it's salt that we don't eat, so that's what we mean by table salt. Calcium carbonate, limestone, so that's what it's made out of. Okay, so this is what's actually happening with an ionic compound. So ionic compound occurs when there is a trade of valence electrons between the metal and the non-metal. You can see the sodium has 1 electron and it gives it to the chlorine atom. Once that happens, one becomes more positive, one becomes more negative. Okay, so ionic compound is a donation process of electrons, so to speak. And on this little nicely charted periodic table, you can see where you can find the donations and where you find the ones that give electrons and where you find those that take electrons as well. Okay, so a thing you need to understand, and you can copy down, obviously you can just look at the slides and do this as well, because this is just recording. So we have an ionic compound is made up of a cation, metal, bonding with our anion, non-metal, through ionic bonds. An ionic bond forms when there is a donation of electrons from one to another. Now the whole point is, after this ionic bond has formed, the net charge is 0. So I know here that sodium and fluorine, one is positive, one is negative, but when I add them together, okay, because sodium has a +1, fluorine has a -1, but when I actually write them together, sodium fluoride, the +1 and the -1 cancel each other out because it's a net 0 charge. So that's what we have here. Okay, so that's what we have. Alright, so there is that. Now what we need to get into is obviously the concept of valency. So this is actually one of the questions in the worksheet. It says, what's the valency of the atom of this particular group, each column? Now you can see we go up to 8 in the actual periodic table. This would be actually group 13, 14, 15, 16, 17, 18. Now there's a really simple reason why we call it 3 to 8 instead, just because it will actually tell us the valency. So the valency tells us, okay, the charge number of the atom and also how many valence electrons there are. So we can see in group 8 here, the maximum number of valence electrons is 8. So we need 8 valence electrons here. Group 1 will tell us that we have 1 valence electron. So that's what the groups can tell us. Okay? Another thing we can say is how many electrons will it give away to get a full outer shell. So with group 1, okay, it's a lot easier to give off 1 valence electron to get a full outer shell. So let's say I'm sodium, and if I want to have full outer shell, full outer electron configuration, I want something similar to neon. Neon has a configuration of 2-8. Sodium has a configuration of 2-8-1, 1 being the 1 valence electron. So if I lose that 1 valence electron, I can be very stable, or at least that's what sodium has. So anything in group 1 we want to lose 1 electron, so we denote that as +1. So we're losing 1 negative charge. Group 2 will be 2+, group 3 will be 3+. We know that group 8 is not going to lose or gain any electrons, so we can call it 0. Group 7, it only needs 1 additional electron to have the same electron configuration as neon, so it's -1. Group 6 is -2. Group 5 is -3. Group 4, I think someone asked before, what does carbon or silicon do? It can do either. It can gain or it can lose. Okay, so that's what we mean by charge number and valency there. Okay, that should help you quite a bit with the question.